We'll calculate two generalized integrals. Um, in this integral, we have a condition that x is less than n. And in both these integrals, we have the condition. So this is condition for integral 1, and for condition for 0 and 1 is that s and n is bigger than 0. Okay, let's begin. And this condition is also for 0. So in both of these integrals, we'll replace the variable x and for u. So we'll get x equals 1 u to the power of 1 over n. And we'll use a derivative, differentiate both sides, and we'll get dx is 1 over n, u to the power of 1 over n minus 1 du. And by this changing of variables, we'll get for 0, and here we'll see, so we'll change the variable for both. So this change I'll call t is for 0 and 1, and we'll see what happens in both cases. So for 0, so for this integral, we'll get from 0 to infinity as well, u s over n times, so this is 1 over n, u 1 over n minus 1 du from here over u plus 1, and here we'll get, actually let's finish this integral first and then we'll continue with this one. From 0 to infinity of u as plus 1 over n minus 1 over u plus 1 du. And I will remind a formula for both of these integrals. It's called the Mellin transform. And we'll use the Mellin transform of 1 over x plus 1, and it is the gamma function of s times the gamma function of 1 minus s, and by the reflection formula, this is pi over sine of pi s. And we'll use this Mellin transform for this integral, because the definition of the Mellin transform of 1 over x plus 1 is, this is the integral from 0 to infinity x s minus 1 over x plus 1, and these are equal. So we'll notice that the variable is s plus 1 over n, and we'll get 1 over n, and we'll replace s here with s plus 1 over n. So it's times pi over sine pi s plus 1 over n. And that is the result of the integral. Now this is a really interesting result, because if we actually, s can be 0, for example, if we replaced s with 0, this will just be 1, x to the power of 0 is 1, and we'll just get a familiar generalized integral, which is 1 over x to the power of n plus 1. And you know, it's a really interesting result because it gives you a lot. And this gives you even more because it gives you this integral and the integral with only 1 over xn plus 1. Now I will show how you can get the result from this integral. Now by the change of variables, we do the same change of variables, and we'll get integral from 0 to infinity 1 over n x s over n plus 1 times a u 1 over n minus 1 over x u plus 1. Sorry, this is u du. And we'll get 1 over n 0 to infinity of u s plus 1 over n minus 1 plus u 1 over n minus 1 over 1 plus 1. And we'll notice that this is the same, if we just took this part, is the same integral that we calculate here. And this other part is if we didn't have the x as in the top. So what the result is 1 over n pi over sine of pi s plus 1 over n plus pi over sine pi over n. And that's the result for this generalized version. Now we have a result for both of these integrals and the generalized result. Now this one is kind of anticlimactic because it's just you are just summing an integer, so it just gives you another easier integral. But we did both generalized results, and yeah, they're like really interesting Mellin transforms. Wish to learn more,